Okay, today we have a few examples from exercise 10.4. Start with question 1b. Okay, 1b, if you notice, right, there's a tangent. Okay, so if I were to draw the thing, the circle, here is O, this is A, and this is a tangent there. Alright, okay, there will be one property that we have just learned. Okay, tangent is perpendicular to radius, so straight away I can say that this angle here is 90 degrees. Alright, because of the circle property, tangent perpendicular to radius. So straight away I can say that angle OAT, okay, is equals to 90 degrees. Okay, because this is tangent perpendicular to radius, like this. Okay, next one, right, that we know from this question is we have another point here, OB. Okay, and then we also know that this is 70 degrees, and we're supposed to find X over there. Notice that OB and OA, they are both the radius of the circles, which means that they must be of equal length. Okay, so it means that I can find angle OAB. So I say angle OAB will be equal to 180 minus 70 divided by 2, which is equals to 55 degrees. And you have to write a reason down for this. I say that is because isosceles triangle OAB. So this angle here is 55 degrees. Then if I want to find X, okay, X is simply equals to 90 degrees minus 55 degrees, which is equals to 35 degrees. And we are done with angle X. Okay, now I do the next question. Question 3. Okay, question 3, they say that TA is tangent to the circle. They want you to find the radius of the circle. Okay, now I sketch the diagram. So we have O, A, then we have this thing here. Okay, now they know that they tell us that BT is 3, AT is 5. We will now label things that we actually know. We know that OA and OB are both the radii of the circle. So this is R. This is R as well. And OAT is equals to 90 degrees because tangent is perpendicular to radius. That's why OAT is equals to 90 degrees. Now the question actually asks us to find what is the radius of circle. So first I say let radius be R down there. Then we know that if it's a 90 degrees, a right angle triangle, we can apply Pythagoras' theorem. So I write by Pythagoras' theorem, OT square, which is 3 plus R square, is equals to R square plus 5 square. C square equals to A square plus B square. And now we start to solve this equation. So what we do first is we expand this bracket. It says A square plus 2AB plus B square is equals to R square plus 35. So you minus R square on both sides, we get 6R equals to 25 minus 9 is equals to 16. And R is equals to 16 divided by 6, which gives us 8 over 3, which is equals to 2 and 2/3 cm. And we are done with question 3. I do the next question for you, question 4. Okay, question 4. Find the marked unknown angles and sides. Okay, there's O. Then we have something like this. we have O, A, T, B. Okay, this is Y, this is 65 degrees, and this is X. Okay, now straight off the bat, we can actually find the value of X. Quite clear that X, right, is actually equals to 65 degrees as well. Okay, because here OT will actually divide the thing, right, exactly into two, because these two are tangents from external point. Alright, so these two are equal. Straight away you can say X equals to 65 degrees, and reason being tangents from external point. There's this thing, AT equals to BT. Here's OT. It will divide this angle exactly into two. The proper term for it is that it bisects the angle. Okay, now next thing, we know that OAT is equals to 90 degrees. Okay, so I say angle OAT equals to 90 degrees is because tangent is perpendicular to radius. So therefore Y is equals to 180 minus 90 minus 65 is equals to 25 degrees, and this one, the reason being, is angle sum of triangle. And we are done with angle Y. Then that was question 4A. Sorry, did not label properly. Now I do for you question 4B. Okay, question 4D, it works like this. And let me try and sketch the diagram very quickly. Yes, O, A, B, and T as well. Okay, then we have an angle X down here. Alright, and then with this angle here is 54 degrees, and this angle here is Y. Okay, straight off the bat, right, I can say that AT is equals to BT. Okay, because these two are tangent to the circle and they link to an external point T here. So we can say that AT equals to BT, and the reason being tangents from external point. Then straight away, since AT equals to BT, this forms an isosceles triangle. I can immediately say that X is equals to 180 degrees minus 54 degrees divided by 2. That is equals to 68 degrees. So now I know that this is 68 degrees. This will be 68 degrees as well. Okay, now how to find Y? Okay, first and foremost, I know that OAT and OBT are both equals to 90 degrees. Okay, because these are tangents perpendicular to radius. Okay, tangent perpendicular to radius. So I'll say angle OAT equals to angle OBT is equals to 90 degrees, and this is the reason being tangent perpendicular to radius. Now finally, how to find Y? Notice that we have OABT. OABT is a quadrilateral. What we know from lower sec mathematics is that for angle sum of quadrilateral, okay, angle sum of quadrilateral is equals to 360 degrees. So if I want to find Y, Y is equals to 360 degrees minus 54 over here, minus 90 minus 90. I will be left with the last remaining angle Y. So just key everything into your calculator. 360 minus 54 minus 90. I am left with 126 degrees. And the reason being, angle sum of quadrilateral equals to 360 degrees. And we are done with all the examples from 10.4.